Hello and warm welcome to today's episode, and today it's all about mirroring again, specifically open mirroring, and this time I want to show you a solution which I've built is to mirror data from a Postgres database, which can be anywhere, also on-premise, and how to mirror the data from tables from this Postgres database to Fabric using the open mirroring functionality. So I will cover shortly what is open mirroring in case you haven't seen this in my other videos. And then I will talk about how to set up the solution. And as a last part, if you're still there, I'm also doing a deep dive on how the solution actually works, the different components which are part of it, so that you get a feeling also how it technically looks like under the hood. So without further ado, let's have a look on open mirroring shortly. So open mirroring Microsoft Fabric is a feature which has been there for quite a while. It's also generally available now, so no longer in preview. And what it basically does, it's taking the mirroring process of Fabric, which is there to replicate data from specific data stores to Fabric in a managed way with zero ETL. It basically uses the same concept and allowing you to build your own mirroring solution. In that sense, that you bring your data, kind of the change data, into a so-called landing zone of a mirror database item, and Fabric is making sure that it picks up those changes, doing the processing and aggregating all the changes over time you feed into this landing zone to merge that together into tables. So in the background, you have delta tables lying there in one lake. You have a SQL Analytics endpoint directly as part of this mirror database item to query it. You can shortcut these tables and include it in your other lake houses. So it's a pretty cool, elegant way how to bring data in. So the tricky part, as always, is how to bring the data into this landing zone, how to collect the changed data from your data sources. And today I will cover how you could do this with Postgres databases and tables within those databases. But before going into the details how to set it up, I also want to show you quickly how it looks like in the end. So what can you expect of the solution? Basically, looking at my Postgres database, which I run in my local setup, I want to have something here which allows me to, looking at my, for example, here my users data table, if I have some changes over here, being reflected that in near real time in my Fabric environment. So if I see, having like this aggregation here and seeing, okay, I have 8,481 entries, and this is kind of the sum of IDs, just to have like some kind of checksum over here to see this reflected in Fabric. So that in Fabric, if I run the same query, that I can see the same changes over here. And basically, if I run some inserts, some updates, some deletes, okay, checks out on the source system. Let's say I want to add some new values over here. That if I have these kind of new 4 inserts, I see this is run successfully. I see that I have 4 entries more now, that this is reflected in Fabric as well when I run this query. So now with a delay of, I don't know, like 1-2 minutes, I actually see the reflections over here. And obviously this is a very small example, but this also works on larger scale. So to get the solution set up, what you have to do is basically go to my GitHub repo. I will share the link in the description of this video. You go to this GitHub repo. There's also quite some documentation, what it's all about, how it is set up. But basically for the installation, what you have to look for, to run this locally or kind of connect to your on-prem Postgres databases, you need to have some kind of runner, some kind of agent system which is doing this mirroring process. That also makes sure that from a networking perspective you can just push those changes to Fabric, so you don't have to open some firewalls, at least like inbound firewalls. What you need to do to run this kind of agent is to use Docker, and specifically also Docker Compose. You have somewhere this PostgreSQL server. It can also be multiple servers running and accessible via this agent machine. On the Fabric and Azure side, on the Fabric side, you need some kind of Fabric workspace and a mirror database item, which you want to use here. And a service principal. So having like this identity, a technical identity, which does the actual push mechanism for the authentication. And he should be, or this service principal should have the contributor on the Fabric workspace. So that he is able to push the data to the open mirroring landing zone of this mirror database item. What you need as well is like the Postgres server needs to be set up in a way that it allows for this CDC connection, and that basically means it needs to be set up that it has a logical replication enabled. It also needs these settings here for or minimum settings when it comes to max VWAL senders and max replication slots. So this is not 0, but some higher number, allowing you to create those replication slots for the logical replication. And then you can get started. You basically clone this repository, configure some environment variables, and the rest is already Dockerized and set up to work in conjunction. So you just run a Docker Compose up and it's getting started. So I will show you quickly how I would do this now on my machine. So to find this Postgres conf file, I have installed a Postgres locally on my machine. So if it's installed like under this location here, then typically in this data folder you should find like this PostgreSQL conf. So it should be somewhere around here. If I open that, I basically have like this large configuration file. So what we're looking for is like this WAL level. So basically finding the setting here, if it's commented, uncommented, set it to logical. The other stuff is like this max val senders. So this should be at least 1, and also the max replication slots. So these are kind of the 3 settings you want to set here for your Postgres database to enable it to basically provide you those change data capture logs. What you need as well is to restart that, to restart the service. That doesn't mean it's deleting the data, but it has to kind of reboot to actually activate those changes. Next step is cloning the repository. To clone the repository, I just fetch the URL of this repo over here, copy that into my clipboard. I've opened a empty folder now in my Visual Studio Code, and then I just git clone this repository. Next, I have to configure this environment variables. Obviously, I need to set up some kind of credentials to connect to my Postgres database, also to my workspace, specifically the mirror database item in Fabric. So basically connecting those 2 dots from a data source to the destination. These are kind of the configurations I need. So connecting where this database is, and there it's like it has to reach it, to the host, the port, and so on. It doesn't have to necessarily run on the same machine, but like from a network perspective, it has to kind of resolve this host here. And you can specify also which kind of tables you want to mirror. So there's like this Syntax here, you have the schema dot table name, and then so you have the database name that's separate, but then for the schemas and tables, you can always have this comma separated list of tables you want to mirror. Yeah, so you can set this up for multiple tables as you like. And for the Fabric part, you basically have the mirror database ID, the workspace ID, and like the credentials of the service principal, which is authenticated or authorized to run the landing of the files in this open mirroring landing zone. And then when it's done, I can basically start the services. So you might ask where to find actually like the mirror database ID and the workspace ID. I mean, that's on the Fabric side. Yeah, if you're creating a new mirror database item, so looking for mirror database over here, just creating that, give it a nice name and click create. What you end up with is like an item like this, mirror database. And if you click on that, make sure it started the replication, and then you find exactly the mirror database ID over here. The workspace ID, you can find this in the URL. So between like this slash after groups and the slash before mirror database, that's actually the workspace ID. And with that being said, we should have all the kind of IDs and credentials to get it started. So I go into this Docker Compose YAML within this cloned repo, and then I fill out all these values I want to change. Yeah, how to find the host, if it's on the same host machine running, where I have the Docker Compose running, it's like this. If you, I mean, there's also some, I commented out, but you can also run a Postgres directly as a container also in this Docker environment if you like, if you set this up initially. Anyway, like for reports, the database, username and password, use those credentials of a user which has the right permissions. Then you can figure which kind of tables you want to use. Yeah, so I have 3 tables here, all in this public schema. And then I have some configurations here for the maximum number of messages to be proceed in one go. Should it read larger batches or smaller batches? That's up to you. And the same also for timeouts. Yeah. So if you would say like, I want to make sure that every 5 seconds or so something is pushed or slower or faster, whatever you want. And then obviously those credentials over here. So I'm just kind of using my values now. With the configurations done, I basically just navigate into this folder here, and then I run docker compose up and get the party started. So it's building this image using some pre-configured images and running the whole kind of setup over here. So on my local machine in Docker desktop, I can now see those images, Docker images, which just spin up, and I can look into this mirror Postgres container and see the logs if it's working. So initially it takes some time until everything, all the kind of interconnections are there. It's kind of resetting mirrored tables which might be already there. If not, it's creating those new. And then the listening part actually starts. So it's fetching new changes, like doing also the initial snapshot for all these 3 tables. So for public users, for public orders, for public products. And in the end, it's like an infinity loop. Yeah, so it will always pick up new changes from these 3 tables which I have configured. And with that being said, I can now switch over to the mirror database item in Fabric and see what is landed there. So on the Fabric side, I see now in this mirror database item, I mean, it's often not automatically refreshed. Clicking on this refresh button it will show me that the replication is running for all these three tables here, like specifically in the users table where I have some changes. I see that these Parquet files with the changes are coming over. And if I refresh that, I eventually should see that there have been some rows replicated. I can also check out like the SQL endpoint now to query the data. So loading over here, I can see in this DBO schema, I have the user table, and now I can also run a query against it. So running the query, I see that there are a lot of rows coming over. I mean, eventually I want to check if I have the same kind of data in Fabric and my Postgres database. So I will check what I have in the Postgres database first. So to do that, using pgadmin over here. So I'm connected to the same database here. I'm running some count here. So I have 8,000 rows, 8,477 rows in this public users table, and I sum all the IDs. So to see like basically a good indication if I have the same IDs than in the target. If I run the same query now, so copy pasting that over to Fabric, it's not public users here, it's DBO users. I mean, I can also use the schema, a different schema if you like, but for simplicity, I use that one. Running that query in Fabric now, I see I have 8,477 users and 4680534 4680534. So I have exactly, or very likely exactly the same IDs here and the same count. So I have the replication of this users table. We can also check if I'm inserting some new values over here. So if I these have to be unique, so I'm just adding some random noise here. If I'm adding some new entries here, so basically I have 4 inserts on this replication engine, like on the connector which I've built. I see it red now for changes and uploading that, and this will reflect within this mirror database item. I can see it. I can see that there's something uploaded. So if I refresh the page, I should see like that there's like 03 uploaded now, and there should be some replication. And if I refresh that, it should show me, yeah, there has been something happening here. Rows have been replicated. And if I look into the SQL Analytics endpoint now, or compare those queries again, so now I have some more entries, 8,481, so exactly 4 entries more. If I compare that on the Fabric side, I'm running the same query over here. I can see that I have also the new counts, and this ending with 530, so I'm also having the same IDs. So I've run this with all kinds of tests here, also with delete and update statements, and it's always kind of picking those changes up. So this, how it looks like, this is how the mirroring will in the end look like. As I mentioned, it's kind of the setup is pretty straightforward. It's all kind of containerized and packaged together. So I hope you have fun with that. So that's how it works. Now I will also want to deep dive a little bit how it actually runs in the background, which kind of components are used and how you might want to modify those. So basically how the setup looks like is on top of your Postgres database, if you have this logical replication enabled, what you can use is a so-called Debezium connector, which is open source project which allows to use that, run this also in a container and connect it to your Postgres database, fetching the changes there, and putting them as messages in a Kafka topic. So having like Kafka running, setting up those topics and putting, so for each table you have a different topic, and it's putting those changes as messages in this topic, also indicating, okay, which kind of values specific row now has, and also which, was it an update or was it a delete or a insert statement. And what I can do now is basically I read from this Kafka topic via some Python script, which also does like the initialization, like building or configuring this Debezium connector, configuring all the connections, and also making sure that the mirror database in Fabric is set up. So this is all encapsulated in this one small Python app. And this Python app will run continuously and read from those Kafka topics and bundle this together. So via these kind of maximum of messages, or like this timeout, which you can configure, and will kind of make those kind of micro batches of messages, bundle this together, bring it into this compliant format to open mirroring, and actually uploading those changes to this landing zone of this open mirroring database item. So if we look at this in the code, so that the main entry point is actually this mirror Postgres py, which does like the initialization part, and then it runs in a continuous loop, also iterating over all the tables you have specified. And it basically builds these Parquet files, which needs to be uploaded to the landing zone of this open mirroring item. And building this Parquet file and then doing the actual uploading part. On the other side, if you look on some utils you can find over the other Python files, feel free to configure that however you like. And you just have to rebuild the container again and then start it again. On the Debezium connector side, I have this script over here which helps you to connect to it. Specifically, I run this recreate connector when the container is starting, and basically it's configuring this Postgres connector of this Debezium connector with all kinds of variables. So this is, you can either hard code it and rebuild the container, or like hand over those variables via environment variables. So this script is basically how to manage this Debezium container and the Postgres connector for this Debezium connector. And so what you end up with is actually a small Docker compose setup. So we have once the kind of custom logic now with those scripts here bundled in a Python container. You can find the definition here in this Docker file, so it's pretty easily set up. It's just running this mirror Postgres py. The other components are out of the box here. So I'm using like a Kafka image from Confluent Inc. I'm using a schema registry from Confluent Inc. And I'm using like this Debezium connect container. This has the advantage that it has all the kind of plugins already installed. I just need to run this API call against it at the beginning to do some configurations, but I don't have to do much else. What is optional, or depending on your setup, you can also have like Kafka UI to directly look into the topics and see the messages in the raw form if you like, but this is actually not needed in the running system. And obviously if that's more for test purposes, to be honest. Running like a Postgres DB directly as part of this system. There you have these kind of configurations you can send them via parameters when starting the container. One last thing I wanted to mention specifically, if you're trying to build your own open mirroring solutions, what is pretty crucial is actually to build this parquet form file in the right way. Eventually, you have to always iterate up. Yeah, so you always have to look up what is the latest file name here, and add one number. But specific to building this parquet files and don't run into issues that the schema is not compliant, you actually have to build this schema for yourself. So what I use for my open mirroring solution is using like this PyError library, and really also derive from the data source what are the different data types, and basically use the appropriate PyError data types. Otherwise, you won't have the right kind of data types in your Fabric system. Yeah, so you might want to do some kind of mapping of what kind of fields do you have in your data source table, in this case in the Postgres table, and do appropriate matching with PyError data types. Otherwise, you won't have this match. Yeah, I mean, eventually, if everything is a string data type, it eventually goes through, but then you would have to do some downstream within Fabric, some kind of transformation to get the right data types. So that's actually a crucial part to make sure that this works. So this is all I wanted to show you today, how to use open mirroring to mirror Postgres database data into a Fabric using the open mirroring functionality. I hope you learned something today. You could make use of it, or maybe extend it, maybe make it a nice managed solution, whatever you like. Take the code, feel free. Thanks for watching. If you like content like this video, subscribe to the channel. Leave me notes, write me messages, what you want to see. Thank you for watching, and see you then. Bye.